Welcome to Algebra 2. Today we've got section 10.4, good buddy, probability of disjoint and overlapping events. All right, so what are these disjoint overlapping events? Well, we've talked about independent events, and we talked about those as being an and case, when we had one thing and the other happening, and we found those probabilities through multiplication. But that's not the only way that two events can occur. Maybe we want one or the other. It doesn't necessarily have to be both. Well, that's where this disjoint, overlapping terminology comes into play. So disjoint or mutually exclusive when they have no outcomes in common. And two events are overlapping when they have one or more outcomes in common. And you'll see when we get to the next slide that sometimes these are working with each other. Sometimes they have no bearing on each other. And it's up to us to kind of sort out what they have in common, what they don't have in common. And it basically comes down to breaking it down into ands and ors, and that's what we'll get to on the next slide. But here, let's just get a little bit of practice of seeing a situation and what we should be visualizing to determine what these two outcomes have in common and what they don't have in common. So here, okay, we are rolling a six-sided die, and we've got two different events. We've got event A, that's where we roll a 2 or a 4. So I'm going to go ahead and make that one of my circles here. And then we've got event B, where the result is an odd number. Okay, so now let's think about placing the different die rolls into places on our Venn diagram. So obviously, if we have a 2 or a 4, we have those two outcomes over here. And nothing is going to go in that overlapping section in the middle because a 2 or a 4, neither of those are odd. Okay, event B, we roll an odd number. Well, we've got 1, 3, and 5 for our odd numbers. And again, none of those are going in that middle section because none of those options fall into the same category as a 2 or a 4. Okay, and then lastly, we could roll a 6, but that doesn't fall in either category, right? It's not a 2 or a 4, and it's definitely not odd, so that kind of falls just in that rectangle outside our two events. All right, so now we're going to use that Venn diagram to find some different situations. So letter A. What is the probability of rolling a 2 or a 4? Well, I can see in red, inside that circle, I've got 2 possibilities out of the 6 total possibilities in the sample space when I roll a 6-sided die. So that probability is 1/3. Letter B. Probability of event B, the result is an odd number. Well, I could get a 1, a 3, or a 5. I'm looking at the blue circle right now. So that is 3 ways I could get event B to occur out of my sample space, the 6 possible numbers that could show up when I roll that die. And that's a 1/2 probability. Then letter C, the probability of A and B. Okay, well, that means the probability of A and B both occurring. Well, let's see. Is there a way that I can look at this Venn diagram? Can I roll a 2 or a 4 and have it be an odd number as well? No. So how do I express that being impossible? The idea that we have this complete void of outcomes that include both event A and event B. Well, that is a 0 probability of that happening. It will not happen. And then letter D, the probability of event A or event B. So just think of this at its most basic level. You can probably answer this without any mathematical knowledge whatsoever. That's why we're doing it before the lesson. Okay, so how many possibilities, how many ways could event A or event B occur? Well, I could roll a 2, a 4, a 1, a 3, or a 5. Any of those options fall under event A or event B. So 5 possibilities out of my sample space is still a 6. So now we were not looking for the and case where they overlap, but we're looking for the or case where it falls within the entirety of our Venn diagram. And in this case, 6 was the only option not included. All right, so a nice little visual cue. So here's some terminology to kind of back that up. compound events. This is what I meant when I'm meaning ands and ors. Are we looking at the union of the two sets? And that's kind of what we saw in our little introduction there. The union, you can see the shaded region includes all of A and all of B plus what overlaps. We refer to the union as the probability of A or B. Sometimes you'll see that union shown as a U without a tail, so A union B. Okay, and then in the middle you can see the intersection. That's where we saw that occur definitely with our independent events. That's P of A and B occurring. And again, we can use some shorthand notation there, A and B. That's kind of an upside down union symbol, means intersection. Okay, and both of those are situations where we do have overlapping events. You can see there were some outcomes that fall into that overlapping area if we were to draw it in a Venn diagram. But it is also possible that, like in our last example, we have what's called a disjoint situation where the intersection is empty. We still want A or B to happen, but now there's no overlapping area in between. Okay, so how do we calculate these compound events? So now really breaking it down into ands and ors, when we're dealing with an or situation, which is the majority of what we're talking about today, we are adding the probabilities together. And we saw that in the last example here when we did the probability of A or B. That was like taking probability of A plus the probability of B. And that's how another way we could have come up with that 5/6. We just looked at our Venn diagram, but that's how the probabilities tie in with this. All right, so we can see we've got two situations. If A and B are any two events, we don't know if they're disjoint or overlapping. Then what we're going to do is we're going to take the probability of A and the probability of B, add those up, because it is an or situation, probability of A or B. But imagine that we had an intersecting union, an overlapping case like in our first diagram up here. If I take the probability of A and the probability of B and I add those up, I've added these four in the middle twice because they're a part of A and a part of B. So we need to subtract one of those in order to only count them once, because those four possible outcomes should only be represented once in our sample space. So that's why we subtract the intersection there. It's because it was counted twice. Fortunately though, if A and B are disjoint events, then the probability of A or B is simply adding up A and B, their probabilities respectively, because there is no overlapping portion. Main thing to take away is that or means add. All right, example one, events A and B are disjoint. Find the probability of A or B. Okay, well, probability of A or B is equal to the probability of A plus the probability of B. And I do not need to subtract because they made the statement that it is disjoint. So the probability of A or B is simply 2/3 plus 1/5. We know the probability of each event, and we add those up. We're going to use some common denominators. This would be 10/15, and the 1/5 would be 3/15. So we get 13/15 for a probability. Okay, and it is still a probability that we are finding, so we want to make sure that our answer is not less than 0 or greater than 1, and sure enough, 13/15 perfectly falls within that window, so our answer is viable. As we have seen before, the math itself is very, very easy. It's the interpretation of the problem that's the difficult part. So this example, like so many other sections and examples that we've seen so far this chapter, a lot of work on that interpretation. We want to be good at that because the math's easy once we've interpreted. So here we've got number 10. Of 162 students honored at an academic awards banquet, 48 won awards for math and 78 won awards for English. There are 14 students who won awards for both math and English. A newspaper chooses a student at random for an interview. What is the probability that the student interviewed won an award for English or mathematics. Now, I've got two different ways to do this problem that I can think of, and I'm going to try and work through this, but we'll choose the easiest one first. That way, if you get it, you can just skip ahead, and if not, I just kind of want to show you how some of these things tie together. It's actually pretty cool. So, what is the probability of A or B? Well, it's the probability of A plus the probability of B. And they did say that some students won awards in both English and math. So these are overlapping events. We want to subtract away that overlapping portion, the probability of A and B, because it's been counted twice. All right, so let's see what we get. We're trying to find this union out front. So probability of A, okay, that's won an award for English. Let's say that is event A. And then mathematics, let's say that's event B. Well, they say 78 won awards for English, so 78 out of those 162 students that were honored. All right, 162 would be our sample space then. And then the probability of B, okay, these are our math award winners. There were 48 of those out of 162. Minus 14 students won both awards. So we've counted those 14 students twice. We need to subtract them away once so that they were only counted one time when we're calculating this probability. Okay, and we're lucky these all have the same common denominator, the same sample space. That happens pretty frequently here with these types of problems. So if I add up those numerators, what I get is 112 over 162, which is 56 over 81. And that fraction works as our probability. It is a fraction that is between 0 and 1. It's acceptable. All right. Now, the other way that I saw to do this right away, the other word, right, we've been talking about ands and ors. The other word is not. If you remember, we talked about the probability of not A is equal to 1 minus the probability of A. It's the complement of the event. So ands, ors, and nots. If you can remember those three, if you can break the problem up and interpret it that way, it makes the work much, much easier. All right, so the way to do this is to say, okay, well, what's the probability that the newspaper person interviews somebody that did not get one of those two awards? Oh, okay. Well, let's see. The probability of not getting a mathematics award, that would be not B. Well, if only 48 won awards for math, then not winning an award for math would be 162 minus those 48 award winners. That would be 114 out of 162. Probability of not winning an award in English, let's see, that would be 84. So the probability of not winning a math award or an English award and not winning a math award, ooh, I think I'm making this way more complicated than I need to. I will edit this out. I'm sure that you could navigate it that way, but as I started to go through that process, it just started to be way more work than what was necessary. There are certain situations I'm sure we will cover where using the complement is advantageous, but for now, we'll just stick with our basic compound event work here. So apologize for the confusion. All right, we're back to rolling our six-sided die. Find the probability of A or B. All right, so yet again, probability of A or B is probability of A plus probability of B minus the probability of A and B. Okay, so let's see. What's the probability that we roll an odd number? That's event A. Well, I could roll a 1, a 3, or a 5. That's 3 outcomes out of 6 possibilities in my sample space. Event B, you roll a number that is less than 5. Well, that could be a 1, 2, 3, or 4. 4 possibilities out of my sample space of 6. Minus, how many of those possibilities are odd and less than 5? Well, I could have 1 or a 3, so that's 2 out of 6 possibilities that meet both criteria. Okay, and if we, again, we have nice common denominators to work with, we get 5/6 for the probability of getting event A or event B. Okay, and that makes sense too, because what is the only way we could not meet one of those criteria? It's by rolling a 6. So 6 is really the only outcome that's not part of our compound probability here. All right, and example 4. I really like this because it brings some algebra, some very basic algebra, into this probability process. Company paid overtime wages or hired temporary help during 9 months of the year. Overtime wages were paid during 7 months, and temporary help was hired during 4 months. At the end of the year, an auditor examines the account records and randomly chooses 1 month to check the payroll. What is the probability that the auditor will select a month in which the company paid overtime wages and hired temporary help? Now, I like this because the interpretation is a little bit trickier. Okay, we do see the word or, but we also see the word and. So we're probably thinking, do I add them up? Do I multiply them? What am I doing here? So let's just start with our or situation. So probability of A or B is equal to probability of A plus probability of B minus the probability of A and B. And the nice thing about just starting with this formula is that it incorporates both the or and the and into one equation. So we can work with both of those at once, which is really nice because we do have or and both given in the prompt. Okay, so let's say the overtime wages are event A, and the temporary help is event B. Okay, so overtime wages, that's event A, were paid during 7 months. So event A is 7 of the 12 months that that auditor could possibly choose. Temporary help, that's event B. That was hired during 4 months, so 4/12. 4 of those months out of 12 that the auditor could choose. Okay, and then the first line, paid overtime or hired temporary help during 9 months out of the year. Well, that's what this is, A or B. So that's 9 of the 12 months. We're able to fill in that. We're not solving for that anymore. What we don't know is the and. So we are solving this for the and portion. And it's just an algebra problem. Just imagine that this is the x that we're looking for. All right, well, on the right-hand side, I do have 11/12. Again, very fortunate to have common denominators. So if I subtract those 11/12 from both sides, I have -2/12 equals negative probability of A and B. So that means the probability of A and B is +2/12, or 1/6. You may have noticed that in some previous lessons, I've just gone right into the numbers right away. But now as we start getting into compound events, we get a little bit trickier problems that we're trying to solve. Laying it out, using the variables, using that probability symbology, I guess would be a good word. But laying that out each time, you notice I did that on every single problem pretty much. That helps me figure out where the numbers go in the prompt to help me establish that I'm doing the correct operations with it. So I strongly encourage you to do that. I think it's a great help in organizing your work. And that does it for section 10.4. Here's a look at your assignment for this section. It's a short one, but again, we want to focus on the interpretation of the problems. Once we get that down, the math becomes very easy.